In the US, slavery was legal until 1865 when the Big Man Abraham stepped up and said it wasn't cool. Yet today, the average Big Mac combo in California is a whopping $18. So how does the dairy industry impact today's stock market? One word, calcium. Speaking of calcium, I have a science assignment about minerals due in 3 days. So it says research minerals that are found in your area. I guess we have to go get some rocks. So, you may be wondering what I found. Well, I'ma be real, absolutely nothing. Anyways, moving on, let's answer the first question. What features about minerals stand out to you? Well, for me, it has to be their color, shape, and crystalline structure. Like how obsidian is black and sharp, or how amethyst is a rare purple color. So now for the big question. How are the features related to the chemical composition of the material? Let's first start with finding a mineral. Okay, we got azurite. Good thing I'm an azurite expert. So, azurite, as a carbonate material, owes its blue color to the presence of copper ions within the crystal structure, or otherwise known as its crystal lattice. The colorization of azurite is a result of a process called electronic transitions. In its crystal lattice, azurite contains copper ions. These copper ions have certain electrons in their outer orbits, and when light interacts with the mineral, some of this light energy is absorbed by the electrons in the copper ion. Specifically, the absorbed energy promotes electrons from lower energy levels, or orbitals, to higher energy levels within the atom's electronic structure. This process is known as electronic excitation. The energy levels in the electronic structure of copper ions are quantized, hard to say that word, meaning that only certain discrete energy levels are allowed, basically sort of like a ruling. As a result, the absorbed light energy must match the energy difference between these levels for the electronic transition to occur. In the case of azurite, this energy corresponds to wavelengths in the blue part of the visible spectrum, which is why we see it as blue. The specific shade of blue exhibited by azurite can vary depending on factors such as the concentration of copper ions, impurities present in the crystal lattice, or if you're colorblind. TLDR, azurite is blue because copper ions mix with light inside it, where electronic transitions lead to the absorption and emission of light into the blue part of the spectrum. Now let's talk about formations. Take quartz for example. Quartz is typically found when it's formed when magma cools and solidifies underground. As the magma cools, silica-rich fluids are put out and can crystallize to form quartz, which usually forms in veins within surrounding rocks, which is why it's always found like this. So, how is quartz so strong? Well, quartz possesses a crystal structure made out of silicon oxygen tetrahedra. That's long. Each tetrahedron consists of one silicon atom bonded to 4 oxygen atoms in a tetrahedral arrangement. This structure is very stable and is why quartz is so strong. In fact, quartz is one of the hardest materials known, ranking 7 on the MOHS scale or MOS scale of mineral hardness, which is quite good. This hardness is due to the strong covalent bonds between silicon and oxygen atoms within its crystal lattice. It's also a pattern throughout the quartz, allowing it to have much purity, which allows light to pass through the crystal with mineral scattering, making it transparent and translucent, which is why it looks quite beautiful actually. Now finally, how have people manipulated mineral structure for their own needs? An easy example of this would be how humans cut minerals for aesthetic designs and fashion. For example, just like if you made a necklace out of azurite. Maybe that would look bad honestly, but still. So people just cut minerals so they look more brilliant, colorful, and have more clarity. Another example could be just like when people are using limestone for building. They cut it and manipulate it, and well, yeah, they use it for like flooring and whatever. Anyways, thanks for watching, and I guess check out these chickens.